Hi, today is the lesson of 1.1 from your functions class, aptly entitled Functions. So we're going to be taking a look at domain and range of relations and determining if each relation is a function or not. And we need to, of course, justify our answer. So here we take a look at this mapping diagram, and we see that we've got two ovals with values in each. And the first oval here represents all the x values, or the domain of this relation, and the second oval represents the y values, or the range of the relation. So we see that -1 maps onto 5, and also -1 maps onto 6. As well, we see 0, 1, and 2 all map onto 7. So if we want to determine if this is a function or not, we take a look at, first of all, the easier part here is we've got 0 mapping onto 7. So when x equals 0, y equals 7. 1 maps onto 7, so when x equals 1, y equals 7. And when x equals 2, y equals 7. So basically those are just 3 points, 0, 7, 1, 7, and 2, 7, which is a horizontal line where y equals 7. So that's okay in terms of whether this is a function or not. Then we take a look at -1. And we see that -1 maps onto 5, and also -1 maps onto 6. Here's where the problem lies, if this were to be a function, because for any relation to be a function, think about this for a second. What's the condition for a relation to be a function? We need that the x value, or every x value, map onto one y value. Okay, so because this x value, -1, maps onto two y values, then that means that ultimately, if you were to simplify things, it would fail the vertical line test, which is basically a version of every x value can only map onto one y value. Here we've got 0, 1, and 2, they all map onto 7, which is fine, because each x value maps onto one y value. Okay, so this is not a function. But we'll still take a look at the domain and range. The domain here, please fill this in. Basically all the y value, or all the values in the x oval. So we've got -1, 0, 1, and 2. And the range are just these values for y. Now if we take a look at example B, again, we could either draw this again as a mapping diagram, or we can take a look and see, well, 2 maps onto 3, and 2 maps onto -7, and then 3 maps onto 0. So we know that the first values are all the y values of any ordered pair. Ordered pair meaning a pair of numbers in a specific order, which is in the order of x and y. So the first value in any ordered pair is x, and the second is the y. So the domain here would be 2 and 3. So now we've got 2 written twice, but we don't have to write that twice. You just write it once, and we see a value of 3 there for the second value of the domain. And for the range, we see that we've got 3, -7, and 0. Now, is this a function? We see that 2 maps onto 3 and 2 maps onto -7, and from the definition of a function, every value of x must map onto only one value of y. So here we've got one value of x that corresponds or maps onto 2 values of y. So this is not a function either. Okay, so we're going to move along now to the next example here. And what we have here is we've got a function which is an exponential function, 2 to the negative x minus 1. So 2 to the x, if you can think about what just regular y equals 2 to the x would be, I'm just going to write the function there. That would be the parent function. What does that look like? We know it goes through 0, 1, it goes through negative 1.5, negative 2.25. It also goes through 1, 2, 2, 4. And so the function is basically like this. If I can hit all the points, and on to infinity. So then if we take, so that's y equals 2 to the x, that's the parent function. Y equals 2 to the negative x minus 1. Well, this negative, what does that do with the parent function? Okay, that would be a reflection in the y-axis. And this negative 1 here, that would be a vertical translation down 1 unit. So then all these points become negative in the horizontal direction, and they all get moved down 1. So basically, this line here, what's that called in terms of exponential functions? I know it's the x-axis, but it's also, in this case, for the parent function, it's the horizontal asymptote. That horizontal asymptote moves down to negative 1, and all these other values get moved down and reversed. So this one comes over here and down 1. This point comes over here and down 1. This point flips over here and down 1. And this point flips over here and down 1. So basically this new function, if I can draw this backwards now, okay, that's the new function. So now we have to determine, is this a function? So I guess I should have been calling it a relation all the time. So is this a function? Y equals 2 to the negative x minus 1. Well, if we were to draw vertical lines to form the vertical line test, we would see that the vertical line would only intersect that function one time through any one line. So that means that all x values only relate to any one y value. So that means that yes, it is a function, and we just have to look at the domain and range now. So the domain, because there are no breaks in it vertically, x is an element of all real numbers, and for the range, y is an element of all real numbers such that y is greater than negative 1. And if we move on to the next example,